Chapter 4. We talk about logarithms and exponential expressions. We have to go back and forth between them, so let's talk about that for a second. So a lot of times when we have an exponential expression like 5 squared and it's equal to 25, like this is something that we know is true. 5 times 5 is 25. Well, there's another way to write this, and that is with logarithms. So the first thing you do is you write log for logarithm, and then you take this base number and you write it as this little base number right here, okay? So those two are the same. And then what you do is from this base number, you go across the equal sign for the next number that goes next to the log. And then you go back across the equal sign to be, that's what it's equal to. So this is the exponential form, and this is the logarithmic form. Now, that's going from here to here. You start with a base, across the equal sign, come back. Well, the same thing is if you want to go from logarithm back to exponential. If you start with this, you start with a base, you go across the equal sign, and then come back, and you have this, 5 squared equal 25. 5 squared equal 25. Yeah? That's just an example to help you through the first couple, and hopefully that'll help with the rest of it in some way or another. So number 1 has log base 5 of x equal to 3 to begin with, and all we have to do is change it to its exponential form. So let me put a little box around there so you don't get confused. So we start with a base 5. We go across the equal sign for the exponent, and then come back across the equal sign to what it's equal to. And that's all they want. They don't need you to find what 5 to the third is. They just wanted you to write it in this form. And in the other way, when we start with cube root of 8 is equal to 2, first of all, with a cube root, this doesn't really help us get from exponential to logarithm. This has to be an exponent. So we're going to write this as an exponent first, 8 to the 1/3 equal to 2. And then we can do logarithms. So we write the word log, we write this base number as a little number down, and then we go across the equal sign for the next number, and then we go back across the equal sign to what it's equal to. Okay? So that's converting between exponential and logarithmic. With 3, 4, 5, and 6, it's asking you to use some basic principles. So the idea of the log of 1. So no matter what the base is, if this is a 1, then the answer is 0. That's how logarithms work. And if you want to really look at it, look and see 8 to the what power gives you 1? Well, 8 to the 0 gives you 1. When it's log base 3 of 3, the base matches the next number. And when they match, no matter what they are, your answer is 1, because it's 3 raised to what power gives you this? Well, 1. Okay? Number 5, we're talking about the inverse property, which says that sometimes when you have an exponential expression inside a logarithmic expression, these are inverses of each other, these two functions. So when you have one that has the same base as your logarithmic function, they sort of cancel each other out, and you're left with whatever that exponent is. Okay? And the same goes for if you have ln. Now, ln is a special type of log. So over here, ln is actually log base e. And e is a number. E is about, 2.7 and some change. So it's a number. It's just we call it e. So if it's log base e, rather than writing it like this, we write it like this. So the ln of e to the 11th actually has a base of e. And just like with the 2's, they're going to cancel. And you're going to be equal to 11. Okay? So those are basic properties of logarithms. The next thing we learn are the expansion and condensing properties. So to expand, we want to first deal with multiply on the inside goes to add on the outside. That's me trying to write the notes in some, English form. And you also have divide on the inside means subtract on the outside. Then the last rule you have is that if you have an exponent like these 11s right here, they come down in front as a coefficient. Now these are the three rules to expand, and if we want to condense, we kind of look at them backwards. So we see an add on the outside becomes a multiply on the inside. Subtract on the outside becomes a divide on the inside, and the number in front comes back up as the exponent. So it's just this in reverse for condense. So maybe writing that condense is that, but in reverse. I don't know if that helps you or not. So let's look at number 7. Yeah, you have to go back and pause that if you want to write it down. Number 7, we have log base 6 of numbers. 7 times 3, not 7.3, divided by 5. So the first thing I would do is, I guess I would deal with the time stuff in the top. No, actually, I would deal with the divide first. So this divide on the inside becomes subtract on the outside. And the base stays the same. It's always base 6. Okay? So with the divide, it becomes minus. But this multiply becomes plus on the outside. So log base 6 of 7 plus the log base 6 of 3. That's what I got from this. And then I put that minus log base 6 of 5, and you got the answer. So times on the inside becomes plus, divide on the inside becomes minus on the outside. All right? The next one has exponents, and so it's a good opportunity to see that rule. So first of all, I'm going to deal with the divide. Log base 4, x to the 5th, minus, right? Yeah, log base 4, y to the 7th, okay? So whatever's at the top and then whatever's in the bottom. That's the order. Now these exponents are going to come down in front. Exponents will come down in front of their particular logs. And so this becomes 5 log base 4 of x, and then 7 log base 4 of y. And there's nothing else to do. Okay, that's 7 and 8. Now with 9 and 10, we want to condense it, so we're going backwards. So with 9, we start with the log of base 5 of 375, which is interesting, minus log base 5 of 3. So minus on the outside is going to become divide on the inside. So log base 5 of 375 divided by 3 is what's going to happen. Now we can actually divide those numbers. And that's what they say. They say write the expression as a single logarithm and evaluate if you can. So let's go ahead and divide that. Let's simplify it. So log base 5 of 7 of, let's see, that's 125. Okay? Log base 5 of 125. Now, 125 can be written as 5 raised to the 3rd power. Did you realize that? So 5 times 5 is 25. 5 times 5 times 5 is 125. And the reason why I'm writing it like this is because, oh look, these bases are exactly the same. They match and cancel, and all you're left with is this guy. That's what they want you to do for number 9. So if you ever have just a number that you're taking the log of, and it looks like they could have the same base, go ahead and change him so that they do, if you can. You want them to be the same base. Oops, ln, sorry. 3 ln of x minus 1/4 ln of y. So in the rules that I wrote, you know how we did, I had 1, 2, 3, kind of like in this order. 1 and 2 sort of come at the same time. So anytime you see a multiply on the inside, it becomes an add, divide becomes a subtract. I kind of like doing this one first and then this one. But you know, like I did with this one. So I did the divide one first, and then I did the multiply, and I think that's probably the right way to go about it. But it was always the exponent thing came last when we were expanding. Well, condensing, we're going to do it in reverse. So we got to do the exponent thing first now, and then do these two. So let's do the exponent thing. This 3 comes up, this 1/4 comes up, And we get ln of x to the third minus ln of y to the 1/4, like so. All right, now the minus on the outside becomes divide on the inside. So this becomes ln of x to the third over y to the 1/4. And yeah, you don't have to change this to fourth root if you don't want to. Last thing on this sheet, number 11 and 12 deal with something called change of base. So not for number 11 so much. So this is log base 10 of 3. Now log base 10 on your calculator just looks like log. So if you're using a calculator, and this isn't a calculator that you typically use. So let's pull this calculator up. Oops, nope. Find a calculator. Nope, calculator. Okay, I don't have a calculator on this. Search apps, here we go. Okay. So like with this one, you kind of have to turn it sideways. This isn't my phone, this is somebody else's phone, of course. Anyway, so with log base 3, I think I would have to hit log, and then it shows that up, and I put 3, and then it tells me the answer. This is 0.477. I'm going to round it to 4 decimal places, so 0.4771. Right? So if it's log base 10, that's the common log. That's just the log that's on your calculator, and that goes no matter what kind of calculator you have. But if you have something like log base 20 of 324, the first thing I would do is see, well, okay, is there a way to make the bases the same? I'm going to do that. If I can say 20 raised to some power is 324, then I would do it. But that doesn't work. 20 doesn't raise to anything to give me 324. So I have to change the base. And the way that we do this is we say the log of the big number divided by the log of the little number, of the base number. And that's just a formula you have to know. That's in the notes, change of base. Okay, so log of 324 I can find with my calculator. I can say log 324, parentheses, okay? And then I can hit divide by log, parentheses, of 20. You need to write log twice. And then that tells me the answer. It's 1.929, and that rounds up to 7, 1.9297. Okay, let me check that last one because I don't know this calculator very well. Yep, that's right. Okay, thanks for joining.